So we left our work at the modeling. So this is where we left. This is our proposed model of our 14-story building. So we are left with the retaining wall and the lift walls, and all other modeling has been done. And after that, we will go towards the definition of the material and section properties as per the code. So let us draw the retaining wall by going into draw. All of these are commands which I'm using. This quick commands is visible in the video. You might have noticed that in the recording. But let us go towards the draw floor, and click on the quick draw walls in plane. You can use this command only in plane. Right? So let us draw these walls. You have to select the property you can see at the left corner. Right? So this is the type area that is pair. Right? The wall property, which we haven't defined any property, let us keep it by default. And you have to click this yes, because you want to design it as a pair, right? So pair means pair will act as a column and spandrel will act as a beam, right? So we are using the grid lines to draw our quick retaining walls, right? So click on this. This is story 1. Click on OK. This is story 1 plane, and we have retaining wall in all other at the periphery of the building. So let us draw these. So you can quickly click on that. So we have selected 1 story, so it will only draw in 1 story. On this grid line, you can draw it quickly like we did it for the beams. You can draw your retaining wall. So the retaining wall has been drawn, but the retaining wall will overlap with the retaining wall will overlap with the wall of the lift. So we will delete this. This is the beam, so you have to disappear this beam and select this. This wall, and you have to draw this remaining portion manually by going to draw floor and draw the walls in plane. Right, so click on this joint and on this one and enter. It will draw these. You can draw this one and this one, right? So we have to insert our lift. So I think this is, we have deleted the wrong one. The lift will be in this corner, so you have to delete that, not this one, because this is the stair one. Same is for this corner. You have to delete this wall and you have to draw the remaining by manually by going to draw floor wall and draw walls. Click on this grid and on this point. Right, so we will draw our lift wall in here. We will go towards the draw and we will use this draw wall stakes. Click on this. Here is in the, you have the already built-in shear walls to be used in this ETABS, right? So select your desired section of your lift wall. So this is our lift in which we have, let us calculate, we have 5 feet opening and we have 10 clusters internal dimensions, right? So this is 10 and this is 10, and we have the C shape lift wall. So you will select this C, and now you can define your desired dimension. So this is the 11 feet and 11 feet. This is the internal. So we have 10 feet internally. So you will insert 10. And the wall thickness, we will keep that as default, because we will be using ACI 31814 for the definition of the thickness of the wall. What is the minimum thickness of the wall? So we will keep that as 12. And then what is the normal height is 7 feet, and the wall opening we have 5 feet, right? So this shear wall, the left wall has been defined. Now you can click on OK. So this shape will appear. So if you have selected only one story, so this will be drawn in one story. If you select all story, it will be drawn in all story. So you have to place it right. For example, if you move this to the joints, it will automatically fix itself to the joint. Like here, the shear wall is here. So we have our left wall here. So we'll click on this. So we have again overlapping of shear wall and retaining wall. So we will delete that retaining wall and draw our retaining wall manually. So this is drawn in all stories. So we'll select one story, click on this, click on that. So this left wall has been drawn in this model. So now we have another left wall in this corner. So you can define another left wall for your model. You can use this one. If you want to use this one, let us use some of the tools that is the rotation and that of the move command. So let us disappear the column, floors and beams, and select this and go to edit, replicate command, and it is asking about you different options. It is you want to replicate it linearly or radially. So if you want to replicate in one story, you can do, but if you want to replicate in all story, you have to select all, and then you have to select it again. So all the shells will be selected at the same time. So go to edit, replicate command, and then click on the pick 2 points. So you will pick 2 points. So you will click on here, and we will click somewhere other location, and we will apply. So it has been replicated on that location. Because the orientation of the left wall is different in this corner, so we have to rotate this left wall. So again, we will select this, and we will go to the assign. We can use move command, that is the so this left wall has been placed in here. We can delete that retaining wall, but the face of this left wall is that this way, but we have in our model, you can see is in that location, right? So you can give its local axis, and you can rotate that as well. But let us use this command again. So there is another option I want to use it in here, that is the rotation command. Again 10, and we will keep this as same for the other. The two command I have used, replicate and move. just to show you demonstration how you can use these command using two pick points, and you can duplicate and move your system in from one place to another. So you click on OK. So there is another command. You can see by default it is on the same direction we previously defined this lift wall. It is again the face of this lift wall is in the opposite side, that you want this face on the right side. What you can do, you can change the angle, that is 0, so you can change into 90. So it will change its face to the our required face that we want our opening in this direction. So we can place that in here, and you can draw the remaining retaining wall which we have deleted. This is in all Storey, that is Storey 1. So these are the left wall which we have drawn, and you can see the openings in this retaining left walls, and we have drawn on the retaining wall at the basement, that is in 1 story. So this is the complete model of a proposed building. Now we are left with the overhead water tank and a Monty, right? So there is no significant effect of the Monty, but you must draw the overhead water tank in a model. So let us go to the architectural drawings, and we have our overhead water tank in here in these two bays. So for that you have to define 2 extra stories to model this overhead water tank in your model. So you have to go to the edit modify grids, and you have to click on the quick add story 2 times, so 2 story has been added. So now you can modify. Last time we have modified this, but unfortunately we end up with the error. This is ground, this was first, second, third. I have already explained this in our previous lecture. This is 6, 7, 8. And this was our 12. So now we have added, this is the top one. We have added 2 extras, so let us name it overhead water tank bottom and overhead water tank top, right? So normally the bottom of a water tank is 3 to 4 feet higher than your top slab. So let's keep it at height of this 3 feet, and the height of the tank is normally 5 feet. We will take it 5, right? So click on OK. So 2 extra story has been defined. Let us go into the plane of our water tank bottom. So we have 2 columns up to the base of this overhead water tank, and these twos are F, G, and H from this, and then we have 4 and 5. So you can count it from the left right side. That is, we have 1, 2, 3. So 3 from the left, and 1, 2, 3, 4, 4th from the top, right? So let us go to the model. To the top, because we have this pair these. So let us. So we have 1, 2, 3, and we have 1, 2, 3, 4. So this base we have our river tank. So select these and go to the edit, replicate, Storey, and then river tank bottom. Apply and click on OK. So when you go to the Storey, this will appear. Now you have to draw overhead water tank walls. So you can use this quick draw wall command and go to this and draw these walls, right? So there is no column because we are resisting this water pressure with these walls, right? So go to the view, building view limits, and let us show only these two. So these are the column that is coming from the top. We have beams in here, right? And we have these walls. So now go to the bottom again and select the quick draw slab command and keep it by default because we will be defining it later on. So click here and here. So it is not showing because we have disappeared the floors. So this is the bottom of the river tank. Let us draw the top. So this is the top of our river tank. Go to 3D. So the river tank has been modeled in our proposed 14-story building. If you want to draw the Monty floor, you can draw it, but there is no significant effect of the Monty because when you define the earthquake forces, you take your earthquake forces from base to the top story. You do not include Monty story because the code gives you a direction or allows you not to consider Monty in your earthquake forces, right? So let us go to the view, building view limits, show all, and click on OK. So now the model for the proposed 14-story building has been modeled. One thing is left is that the slab or the lift, it going to the top, click on OK. So you can see that there is a slab in the lift walls. So you can draw your openings by going into the draw, floor, draw rectangular, and select your opening. And select all stories and draw your opening here, right? Same for the other lift because there will be no slab in the lift. So now this model is now complete because we have drawn our. So let us delete this one because we do not have any opening at the top or bottom for our tank stories. Right, so this is the complete model of a proposed 14-story building. Let us go towards the PowerPoint, which we have. So this is our session 4, in which we covered the modeling of a proposed 14-story building that was continue, right? And then part 2 will be defining material properties, and part 3 will be defining section properties of columns and beams, right? So this section has been covered in method 2 and method 3. So now let me save this file. So now we will start working on the definition of the material and section properties. So the first one, the part second, is the definition of material property for concrete and steel bars. And this we have compressive strength FC prime. So FC prime should be defined according to ACI 31814, shall be specified in the table 9.2.11. In this table, the limits for the FC prime is if you are your application is general. For example, if you are designing your system for gravity loads only, and it is whether it is normal and lightweight concrete, the minimum FC prime is 2.5 KSI or 202,500 psi, and there is no limit on the maximum limit, right? If you are designing your structure for earthquake loads or special moments frames and special structural walls, if you are using lightweight concrete, the minimum FC prime is 3000, and there is no limit on the maximum. Same is for the light, but there is a limitation on the maximum FC prime for the lightweight concrete. So we are designing our special moment frame. So the normal weight concrete, the minimum value is 3000, and there is no limit on the maximum. So we will start our definition on material properties. We will go to define material properties. So there are some by default values is being defined by ETAB, but we will define our own. Click on add new prop material and select your region, because we are following ACI, that is American code. So we will select United States, select type, it is whether it is steel, concrete, or rebar. So you want to concrete. And this is standard customary. You can define your own user. So we'll keep it that customary. And it is asking about the grade. Select your grade you want to define. So you want to start from the minimum, that is code recommends for the moment resisting frame. So you will select FC prime 3000 and you will click on OK, right? So a new window will appear which will tells you about the different properties that has been defined for this 3000 psi concrete. The first one is its naming, and then its material, that is concrete. The second one is the direction symmetrical tab, that is isotropic. Isotropic and orthotropic. Isotropic means its deformation and all properties are same in all direction. But if you select orthotropic, a new window will appear and it will have the mechanical property data. If you modify that, it will ask you about the E and G and A, all of these information for different direction X, Y, and Z. So if the material is orthotropic, so the material properties, model of elasticity, its deformation will be different in all direction. But if it is isotropic, the concrete is normally is isotropic, but there are some, if you add different add mixtures and other materials, so it may change its property to from isotropic to orthotropic, right? If you are using normal concrete, which is normally is isotropic. So you can write your notes if you have, and then have you unit where normally 150 for RCC and we have 140 for PCC, that is being defined by the software. And then we have models of elasticity. So there is a equation for using defining models of elasticity. This is the equation that is being defined by the code, that according to a CI3 model of elasticity can be calculated as per the given equation. So for the for the values of unit weight of the concrete between 90 to 160, this is the general equation. But for normal concrete, it is 57,000 under root FC prime in PSI. So if you insert this value, let us do this practice. If you want to calculate this, or want to verify the value calculated by the ETABS for the FC prime of 3000, so it comes out to be 31,22019 psi. If you divide this by 1000, it will give you the value in psi, that is 3122 psi. So let us go to the ETAB. So we have same 31. If we divide this by 1000, we have 3122. So this is in pound per inch. So it will be converted into KSI. Is the meeting is going?
Yes, sir.
Yes, sir.
So this is the Poisson ratio. Normally it is 0.2 for the concrete, and this is thermal coefficient of expansion. And we have this design property data where you will specify the design strength. So click on this modify. So we'll have this window, and here is the FC prime value of 3000 is already written, right? So the EC models of elasticity will be calculated if you have other value. For example, if you are defining your FC prime 500 psi or 2.7 ksi or 200 maybe. So you can insert this EC for concrete by calculating using the equation 5000 under root FC prime. So you will click on OK. So we will use this 3000 psi in our slabs and beams. Normally they are monolithically connected, so its concrete casting is done at the same time. But columns are casting separately, but we will define FC prime for columns separately. We will go to add new material and we will select 6000 psi and click on OK. So all the properties same. You can see the modulus of elasticity for 6000 is being changed. You can verify it. By putting 6000 in here. So it is 4415 KSI, which is again, it is 4415. So again, you can check the properties. That is the 6000 KSI, 6000 PSI, 6 KSI. So these are the other material property, advanced property that is used for the nonlinear dynamic analysis. We are not interested in that. So we'll click on OK. We will again define another property for our column because we will be using 6000 and 5000 or maybe 5.5 KSI in our column. So we'll define 4000 and click on OK, and we will change into 4.5 KSI. We will change its model of elasticity. And it is 3822, 3823, 676. And we will change its FC prime value. So this is how you can define any value of FC prime of your desired requirement, right? So we click on OK. So now these three properties has been defined for the concrete. The next one is for the steel. We go down. So the steel bars account ACI 31814. Steel bars to be used shall be from the following given list. So these are ASTM 615, ASTM 706. So these are very expensive. This ASTM A706. The normal standard material of steel that we are using in Pakistan is ASTM A615. This is the common steel that you're using in Pakistan. So we will use that. So we'll go to the limitation of the use different type of the rebars where you can use for the flexure, shear, and torsion that has been defined in ACI table 20.2.2.4a, which is the non-pre-stress deformed reinforcement. For the flexure axial forces reinforcement, the limitation for the specific special seismic system is maximum value of 6000, and the deformed bars is telling you again to refer to this section 20.2.5. For the lateral support means the lateral ties and stirrups, you can use this specific special seismic system. The limit is 1 lakh PSI, and you can use any of these of bars for your structural system. This is for the shear and this is for the torsion. You can select any of the desired. But in our model, we will use 60,000 KSI for all for longitudinal, flexure, and shear and torsion. All we will be using 60,000. Let us go towards this section. That is a CCI referring if you are using for the flexure, axial force, and shrinkage reinforcement. The limit is 60,000, but the deformed bars have some other requirement that is being defined in section 20.2.2.5. Let us go to that section, and that is the limitation on the strength of the deformed bars in the given ACI 31814 table. So this is the section that is being referred by the ACI. If you are using A615 grade 40 steel, so A and 2 must be satisfied, which is these two conditions. And if you are using 60 grade reinforcement, all the three conditions must be satisfied. The first condition is the actual yield strength based on the mild test does not exceed Fi more than 8000 PSI. It means that if you have FY 60,000, so the value from the test that is being conducted in ASTM uniform testing machine, so the value should not exceed 78 psi, 78 ksi, right? For 40, it is should not be greater than the 58 ksi, right? The second one is the ratio of the actual tensile strength to the actual yield strength is at least 1.2. So the value you obtain from the test and the value you have from the design. For example, if you obtain your value 68 from the test and you have 60, so this ratio should be at least 1.2 or greater than 1.25. So this is the third, and this you can this is another condition. Third, elongation in number 8 bar should be at least 14%, and etc. for all of these bars. So you have to satisfy this condition in order to use grade 60, and this condition will be coming from the test that is conducted in UT and other universal testing machine that is other universities, right? So we will go towards the ETAB, and I think this Zoom app is giving me notification that the meeting will end in 10 minutes. So let us go quickly define the new material and select. The steel is actually the structural steel. These are using structural systems, composites, steel members, and we have this truss members. For the reinforcement, we will select rebar, and this is the options which you can select ASTM 615, ASTM 615, and you will select grade 60 when you click on OK. So again, a new window will appear which have this material type rebar, and this is again uniaxial, and this is the unit weight. All of these you can, this model for 60 based on the yield strength of the steel bar, right? So you can verify the design property. So this is the 60, this is the ultimate, that is the 1.5 of this, and this is the 1.1 of this, and this is the 1.1 of this minimum tensile strength. I think I assume all of you know these things. So I will click on OK and click on OK, right? So this is how we define our material property for concrete, and so we can modify its name. Let us call it grade 60 and click on OK. So now we have defined our material properties. So let us end this session because we have only 3 minutes remain. So I will quickly stop this recording, and we will meet in 30 seconds or 1 minute, right? So let us stop this sharing.